Hey, in this tutorial we're going to be looking at section 7.3, which is on antiderivatives of exponential and trigonometric functions. Okay, so what I've done is I've just put together a few identities here, okay, that we can run through. So we say if we integrate cos of x with respect to x, then it goes to sine of x plus c. If we integrate cos of ax plus b dx, then that's going to equal 1 on a, so the coefficient of our x term, times sine of ax plus b plus c. So don't forget, we always have to have these constants at the end, our constants of integration. Okay. Similarly, if we go sine of x dx, okay, then the antiderivative of that is negative cos of x plus c. Or if we want to find the antiderivative of sine of ax plus b dx, then it's minus 1 on a cos of ax plus b plus c. Now the next two aren't actually in the textbook, and it's not essential knowledge for methods, but I think it's a little bit of a letdown if we don't keep going through and just show you what the tan ones are, because we always talk about sine, cos and tan, but when we start talking anti-differentiation, okay, our tan ones get a bit complicated, and so we usually just skip past them. However, for completeness, I want to put them in. So say if we want to find the antiderivative of tan of x dx, there's going to be negative log to the base e of the modulus of cos of x plus c. Or we could put that negative up the top, which means we can say log to the base e of the modulus of sec of x plus c. Okay, now modulus just means everything that's in this is positive, okay, and it'll be something that our specialist students are going to get familiar with. And similarly, if we say the integral of tan of ax plus b dx is negative 1 on a log to the base e the modulus of cos of ax plus b plus c, or we can bring our negative up again and say it's 1 on a log to the base e of the modulus of sec of ax plus b plus c. Okay. So those two aren't essential knowledge. Okay. However, we do need to know how to find our antiderivatives of exponentials, and we should realise that this is going to be quite straightforward, okay, because our derivatives of exponentials are pretty straightforward. So if we finding the antiderivative of e to the x dx, then it's simply e to the x plus c. And we know that because if we take the derivative of e to the x, we get e to the x. If we're finding the antiderivative of e to the kx dx, then it's equal to 1 on k e to the kx plus c. Okay. So we'll keep moving on, okay, and start having a look at some worked examples. Okay, so we want to find an antiderivative of f of x equals 2 sine of 5x plus 3 cos of x on 3. Okay, so we can simply split this into two parts and say, well, we're going to be integrating 2 sine of 5x dx plus 3 cos of x on 3 dx. And also bring our constants out the front and say it's 2 times the antiderivative of sine of 5x dx plus 3 times the antiderivative of cos of x on 3 dx. Okay, so when we do that, we need sine goes to negative cos, and it's 1 over this one as well. So we've got 2 times negative 1 on 5, so cos of 5x plus 3 times sine, 3 times 1 on 3 sine of, it's actually 3 times 1 over 1 on 3 sine of x on 3 plus c. Okay, so because it's 1 over our 1/3. Okay, now notice I didn't put a c value for this part and a c value for that part. We'd have a constant plus another constant. Well, that's just equal to a constant, so we can just use one constant of integration. Okay, so we can finish it off and say we've got negative 2 on 5 cos of 5x plus, well, 1 over 1/3 is 3. 3 times 3 is now 9 sine of x on 3 plus c. Okay, so we're getting there. Okay, we'll have a look at this one now. Again, we could do it in parts, okay, but I don't think we'll worry too much. Right, so when we do this, we can say, well, we've got to be x to the 8 divided by 8, okay, minus, well, we're going to be 1 over our coefficient of our x, so 1 over 3 e to the 3x plus c. Okay, that's all there is for that one. Okay, and we'll keep moving on. We've got, we're just integrating this one now. Okay, so when you think of that as 8 outside of e to the 2x dx, so it's 8 times 1 on 2 e to the 2x, so that's going to be plus c, sorry, so that's going to be 4 e to the 2x plus c. Okay, almost there. We've got a couple more worked examples to go and then we're finished for this section. So we've got find y if dy dx equals e to the x plus e to the minus x cubed. Right. So what we need to do for this is we actually need to expand our brackets, okay, which isn't that nice. Okay, but what we're basically doing, okay, is I'm going to run through the steps quickly. So we've got, when we expand this out, we're going to have e to the x cubed plus 3 e to the x squared times e to the minus x plus 3 times e to the x times e to the negative x squared plus e to the negative x cubed. Right, if you remember, that's actually from our binomial expansion. Okay, when we do that, we can say that we've got e to the 3x plus 3e to the 2x e to the negative x, okay, plus 3e to the x e to the negative 2x plus e to the negative 3x. Okay, we'll simplify that a little bit further and say we've got e to the 3x plus 3e to the x plus 3e to the negative x plus e to the negative 3x. Because we've got the same bases and we're multiplying together, we can add our powers. Okay, so we've simplified as much as we can. Now what we need to do is actually anti-differentiate that. So okay, with respect to x. Okay, when we do that, well, we're going to be 1 over 3 e to the 3x plus 3e to the x, that one's not going to change at all, minus 3e to the minus x, because we're going to divide by, if you like, 1 over negative 1, well that's going to give us negative 1, okay, minus 1 over 3e to the negative 3x plus c. Okay, so we're almost there. What we've got for the next one is given that y equals e to the x squared, okay, find dy dx and hence find this. So we've got y equals e to the x squared, so that means dy dx is going to equal 2x e to the x squared. Okay, so this is one of our integration by recognition questions. Okay, so that means if we were to differentiate 2x e to the x squared with respect to x, then that would equal e to the x squared. Okay, which means we now need to bring our 2 out the front. X e to the x squared dx. Well, we know that's going to be e to the x squared still, so we've got what we want here. Okay, but we've got to get rid of this 2, so we'll divide it by 2. Say that we get e to the x squared on 2 plus c. Okay, to get our answer. Okay, so remember your when we do integration by recognition, okay, we're differentiating something so that we get a function that's similar to what we're trying to anti-differentiate. Okay, set up our equation, manipulate it a little bit so it looks like what we're trying to find. Okay, and then just rearrange so we get what we're looking for. So that's everything there is in this section. So hopefully it's enough to get you through. Yeah, I don't think it's a super horrible section, but see how you go.